Hey guys, so let's discuss new topic from system design. New means designing question from system design, which is called design system for 1 billion users using AI with AI. Okay, so here let's say you have one application, and that so initially only few users were using it, and it was working very nicely. Okay, but now that application is now using entire globe. Okay, so you are having 1 billion users, you're getting 1 billion requests on your application. So how will you design that? Means what all the modifications you will be doing it. Okay, so before jumping onto the AI feature, let's talk about the key design decision for 1 billion users. Okay, so the first one is multi-region deployment. Okay, so what is multi-region deployment? See, your application has 1 billion users. Okay, you're getting 1 billion requests, so it means that entire globe is using it, right? And globe is divided into multiple regions. So so now you need to do deployment in all the region, correct, one by one. So why we are doing it? See, if you have only one region, then that is the biggest bottleneck of your application, because this one will be the single point failure. Why single point failure? See, we have seen in a war situation, people are destroying data centers. Okay, so now if somebody will destroy the data center and your data is there, your entire application will get crash. So now if you have a multi-region deployment, you have your application deployed in multiple region, is one, if there is a problem in one region, then we can divert the traffic to another region. Okay, so that is the biggest advantage for multi-region deployment. So multi-region deployment avoids single point failure, route user to nearest region. Okay, active region. So now what is active region? You have multiple regions, and your application is deployed in multiple regions, but there could be a situation. There are two types of thing. First is active, second is active passive. Okay, so in active passive, your one region will be active and other will be on standby. If anything happens to this region, then only that one will come into action, and then we will divert traffic to that region, because you know that resources are expensive, okay, in cloud based system, and we pay as we use. So in some situation it is active passive, but here that one will be active, means all region will be active, all will serve the traffic. Okay, and for example, India, if someone is sending request from India, so it will go to Mumbai region. If US, then Virginia. Europe, then Frankfurt. So active region, here just I have given you the theory. Okay, means multiple regions are running live, serving traffic at the same time. So instead of keeping one region as a backup, all regions are active and handle users simultaneously. So this is the example they have given, and here is the difference between active and active passive. Okay, so active, all regions are live, so this is the traffic would be shared here, and active passive, one live, one standby, so only traffic will go to primary server only. Okay, so this is the architecture. So here you have a global DNS geo routing. What is global DNS geo routing? See, when you type some application name, let's say google.com, so Google has placed his data center at across the globe, okay, in multiple regions. So when I'm hitting my request from India, so that DNS, okay, domain name server, will resolve that google.com to nearest region's IP address, okay, and then will redirect me to that IP address. So here in active architecture, let's say you have three regions: Mumbai, US and Europe. All three are active. So if US region goes down, traffic automatically shift to Mumbai plus Europe. Okay, so no downtime. What are the benefits? High availability, no single point of failure, lower latency, handles huge scale, 1 billion user. Okay, and we are not talking here about million, we are talking in terms of billion. And disaster recovery built in. So disaster recovery, we have already seen it, right? So it will divert the traffic, so no downtime. So this kind of things is handled in multi-region architecture. Now real companies who is using active is Netflix, Google, Amazon, Meta. Active passive, so just one server will be primary. Okay, so like Mumbai is primary, and you have kept US server on backup. So backup only used when failure happens. So it is slower because only one server, one region is handling the traffic, right? Heavy caching strategy. Second one is heavy caching strategy. So here, instead of using one cache strategy, okay, you use multiple cache strategy, means a hybrid. Okay, so for example, first is CDN. So use the CDN caching. Okay, so you will keep data in CDN also, which is frequently used in a cache. Okay, then you have a edge cache. So cache means edge servers. You have multiple edge servers. Okay, you have one primary server and then edge servers in DNS. So in those edge servers also use the cache. So the region specific data you can cache there. Okay, let's say in one region one thing is very popular, so you can keep that in that region's edge cache. Okay, so that the request will not go and hit the primary data center, which is, let's say, in USA. Okay, and then Redis cache. So you can use for hot data, you use the Redis cache, and then application cache as well, which you use using normal hash map or something, right? So what will be the result if you use all this kind of cache strategy? 80 to 90% traffic never hits DB. Okay, so your application will be very fast in that case. Now database sharding. So single DB wants scale. Okay, so if you have only one DB, then for serving 1 billion requests, that one will not be sufficient. Instead, you just shard it in multiple DBs. Okay, so for example, user 1 to 100 million data is stored in shard 1. Okay, 100 to 200 million in shard 2, and it will goes on. Now event driven architecture. Okay, so use Kafka there for the events. Use Kafka for activity logging, notification, analytics, AI training, recommendations. Okay, so definitely we will use Kafka there. Async processing. So let's say you have call one service. Okay, and now it is doing his work. You have placed one order, and now some services are dependent on this event. Now you just, when you placed the order, you can send notification to user that your order is placed and will be delivered by this date. Okay, and meanwhile, asynchronously, your payment service, your notification service, your delivery service will start working. You don't need to wait for them and then send the response. You just so order service done his work, and then now he can send response to user that your request has been processed. So this one will decrease the latency, right? This reduce latency drastically. Auto scaling. So if you are using Kubernetes in your application, so it will automatically increase the number of pods, okay, or decrease the number of pods according to the traffic. So auto scaling, Kubernetes pods, auto scale, load based scaling, AI based predictive scaling. Okay, so use this one also. So let's say if in your application the peak traffic comes at 9 p.m. okay, so it will auto scale, it will automatically add few servers, and at night time nobody is using your application, so that time it will decrease the number of servers. Okay, so you don't need to pay much, you pay what you use in cloud. Now read write separation. So let's say your application is read heavy. Okay, 95% request is just for reading, and 5% only is for writing. So in that case, no need to use only the single DB, right? You can do one thing, you can create a read replicas. Or write means just keep a read and write operation separately. Okay, so your write will go and write in a primary DB, and read will happen from read replicas. Okay, and eventually it will these read replicas will be in sync with the write DB. Okay, so read traffic, let's say 95%, so huge performance gain, correct? Because they will only read with this read replicas, no logs or nothing, and so they don't need to wait. Now this is the normal billion user architecture. You will have a DNS, okay, geo routing, the nearest region, IP address it will provide you. Then you have a CDN where you will store your static resources and other resources. Then you will have a global load balancer, okay, and then for different regions like Mumbai, USA, Europe, okay, and then you will have an API gateway, and then API gateway will route your request to either for cache, for Kafka, or for AI layer. Okay, we will check what is there in AI layer, and then it will after that whatever data you are getting here, you will do a stream processing with that data. Okay, and then that data you can shard in multiple DBs. So now, important tips. When someone will ask you that you need to create a system which serves 1 billion requests. So large scale system, you can always include about CDN, multi-region deployment, sharding, caching, async, Kafka, load balancing, auto scaling, and read replicas. Okay. So now, if you see the high level architecture. Okay, so what will be the high level architecture? This is the same one, okay, what we just discussed. So your user and then global CDN static data will cache here, and or static cache you can say, okay. And then after that you will have a global load balancer, then you have multiple regions, and then you will have API gateway, and then your system will be further divided into multiple categories. Now okay, now let's now this one will be the per region architecture. Okay, so this one we have seen global level, and then per region again you will have a, let's say you will have the user, and then a web application firewall for security, then load balancer, then API gateway. After that your microservice services cluster, okay, different services slash login slash user, and then cache service, okay, Redis cluster, and databases, sharded one, fine. And after that all the data will come to Kafka event streaming. It will do stream processing, and then will store that data into data lake or machine learning thing. So what is data lake? It is the lake of a data. Okay, so means a data lake is central place to store huge amount of raw data, structured, non-structured, for analytics, AI, and for processing. Okay, then the simple definition you can say data lake is dump everything first, analyze later. So you store logs, JSON, images, video, Kafka events, DB exports, ML training data. All these things will come here. Okay, so now all in raw format. Now design system for 1 billion users with AI. Now we are introducing AI here. So till here that was our normal basic scalable system. Okay, now here we need to design it for means we need to use some AI feature here. What AI feature we can use here? So let's see. So core idea with AI is at 1 billion scale system is not just scalable, it must be self-optimizing also. Okay, if it is self-optimizing, your lots of work will you don't need to do, you're saving time, okay, and resources. So AI helps in personalization. Okay, we will see what is personalization, traffic prediction, smart caching, failure detection, and cost optimization. So now we will take example of Instagram and Facebook here. Okay, now let's discuss all these AI features. So the first this is the architecture, normal architecture. Okay, similar one. So first you will have a, this is AI plus scale. Here you will have user, CDN, okay, load balancer, then your API server, cache layer, AI strat gateway, and then AI service cluster. So this thing has been added, and then database, Kafka queue, and stream processing workers. Now where AI is used. So now let's discuss those points. Personalization feed ranking. We are talking here about Instagram or Facebook. Okay, so you can use personalization in your feed ranking. Okay, so on your home page you see the posts, right? So there, instead of showing chronological feed, AI will decide which post in what order. Okay, for example, Instagram shows post you are likely engaged with. If you like someone's post, so it will show you similar that kind of things. Okay, so feature used is likes, okay, watch time, then scroll behavior, user similarity. Now what is here chronological feed? So let's discuss that. Chronological means order by time. Okay, not randomly, just by time, from oldest to newest to oldest. Example, chronological feed will be post A, which was posted on 9 a.m. Okay, then you will see the post B, which got posted on 5 a.m. or 9:10. So shown exactly in time order. So you are not using much. That is just the static. Okay, you are not using much prediction there, ML prediction. So in social media, chronological feed post shown by what when they were posted, and now here non-chronological post, which we are doing using the ML. So this one will use some algorithms, like it will use likes, relevance, okay, AI. So like chronological post will be something like this: 10 minutes ago, 20 minutes ago, 30 minutes ago, in order. And non-chronological, it will be 30 minutes ago, but that was the viral one, that's why you're seeing that on the top, okay. Then 5 minutes ago, 2 hours ago. So you can see here the time doesn't matter. One line meaning chronological, arrange according to time order. Second one is the smart caching, AI based. So it will decide that what to cache. Okay, so what will be the AI solution? Predict hot data. It will automatically predict that which one will get viral, which one will get most request. Okay, so it will automatically predict that hot data and then put that into the cache automatically. So that is the smart caching. AI is predicting what needs to be added in the cache. So viral post, if there is any viral post, then it will cache aggressively, because now lots of user will go and hit for that. Now predictive scaling. AI predicts traffics, okay, traffic spikes. Example, live event, sudden traffic search. System auto scale before spike. So earlier what we were doing, when request was coming, okay, that time only it was auto scaling. But here, before coming this request itself, it will predict that, okay, there is a live event, okay, for this particular celebrity, then definitely the spike will come. So before that only it will auto scale, so that your initial request will not have to wait that much. Now intelligent feed generation, okay, so hybrid model, fan out on write, fan out on read. So fan out means it will publish for active user, for inactive user. AI decides which strategy per user. Recommendation system. So if you talk about recommendation system will recommend you the friends, okay, the videos or the products. So for example, Netflix recommendation system. So there also you use the AI. Latency optimization, so AI routes request to nearest data center and least loaded server, okay. Not only nearest, but let's say one server is far, but it is least loaded, okay. So if it is least loaded, then it will respond you much faster than the nearest one, right? So that's why. Now failure prediction, so AI detect disk issue or network anomalies, okay, prevent outages, spam and abuse detection. So AI filter fake accounts, spam post, okay, all these things we can achieve by AI. Now the fifth one is end-to-end flow, okay, for the AI system. So let's say user open Instagram, okay, request hits load balancer, cache check. So if it is cache hit, then it will just return. Otherwise, if it is missed, then go deeper, go to database, will take that data, update the cache, will return the response. Then feed service calls AI ranking, okay. First feed service will call AI ranking, and then we'll choose the top post, okay, for you, and then we'll select that post for you. AI select top post, data fetched via Apache Kafka pipeline, okay, and then response returned. So this is the normal flow using AI model. So this is just for your information that which AI model we will be using. So for feed ranking we will be using ranking model, okay. Recommendations we will be using collaborative filtering. It will collaborate for different services and then will find. And then traffic prediction, so time series, okay, because traffic is something which is which comes in a stream format, okay. So there you will use the time series model. Then failure detection, so anomaly detection, and then spam detection, so classification. Now trade-offs, if you talk about here, AI personalization, more compute cost, correct. If you're going with prediction error, then wrong result could also come. Heavy caching, so stale data could also be there. Real-time AI, so latency will also increase, okay. So challenges if we talk about, so it will be cold start problem, okay. So a new user, he will have no data. When you create your Facebook account newly, or when you create your LinkedIn account newly, you will have no friends, nothing, right? So what data it will show on your feed? What it shows global trends, right, those things. Now model drift, so user behavior changes. So what is the currently AI was trained with one behavior, now user behavior has been changed. So what is the solution for that? Continuous retraining. Model will retrain again, okay. Now latency versus accuracy, so complex model definitely will be slow. Now what is the solution? So pre-compute plus caching, okay. Just pre-compute it so that it will save the time. Data privacy, so sensitive user data, what will be the solution? So anonymization, Okay, scaling strategy with AI. So scaling strategy, we have seen that multi-region deployment, feature store. Okay, so feature store is store ML feature for fast access. So the ML pipeline I have already discussed in my previous design videos. The ML pipeline is something like this. You will get the raw data. You will create ML will create feature from that raw data. He will store that feature in a feature store, and then that data he will use for the model training and for the real-time inference. Means real-time, he will take the action. So online versus offline model. Okay, so offline what it will do, it will use for the training, and online what it will do, real-time inference. Okay, it will take dynamic actions according to the result. So real world system, if you see where they are using AI, Facebook is using for AI feed ranking. Okay, the feed you are seeing, Facebook is using AI feed ranking there. Instagram is for engagement optimization, and Netflix for the recommendations. So at 1 billion user, we combine distributed scalable architecture with AI driven personalization, predictive scaling, okay, and then intelligent caching, anomaly detection to build a self-optimizing system. Simple analogy if you talk, so without AI, same newspaper for everyone, and with AI, if you add AI in that, so personalized newspaper for each other. So that's it. Thank you.